Hello, this is my PHYS2212 Lab 2 presentation. The purpose of this lab was to observe the interactions of different charges and compare them to different simulations. Physical principles used in this lab were Coulomb's law, electric fields, and Newton's second law. The observed interactions of the tapes were recorded in a previous experiment, and they were simulated using a point charge model and a line charge model. The results were that the line charge model produced a greater calculated charge than the point charge model. Coulomb's law and the electric field equation relate the charges of objects to the electric field and the resulting force they produce as a function of distance. These equations were used to simulate the interactions of charged tapes and determine the charge on the tapes in the lab. Newton's second law relates the net force on an object to its change in momentum. In this case, the net force on the object is zero since it is still. This observation allows the electric field to be calculated through force balancing. Experimental setup from Lab 1. The system is top tape, the surroundings are the bottom tape. The initial conditions on the tape mass was 0.2 grams. The tape dimensions were 20 centimeters by 1.6 centimeters. K as always. Proton charge as always, and the distance was 17 centimeters. Millimeters. Yeah. In the last experiment, one charge tape was held across a gap, and another charge tape was held under it at a distance of 17 millimeters. Those tapes were charged by quickly pulling them off a base tape, which had previously been attached to a flat surface. Then the tape's dimensions and mass were measured to calculate the charge on the tapes. So here's our glow script setup for this experiment, the line charge model. On the left, we have our electric field function, our top and bottom tape being created as a line charge, and then we have the summation of the charge and electric field they create. The magnitude of the electric force from the tape calculated by glow script is 2.92 e to the negative fourth newtons per coulomb. To determine this, air resistance was ignored. The tapes were treated as line charges, and each U-tape was assumed to be the exact same. The charge of the tape using glow script simulation is 2.0 e to the negative eighth. This was determined through trial and error to see which charge could match the gravitational force to leave a net force of zero. And so, as you can see, here are the differences in our charges from the different simulations. Some possible sources of error from gathering data from the original experiment are air resistance, inaccurate measurements, and uneven charge distributions, as well as inequality of U-tapes. So the line charge model calculated a charge that was roughly 2.8 times what the point charge model did. So why did that happen? The first model oversimplifies what is going on with the tapes. The first model concentrates the line of charge into a single point. However, in reality, they are distributed over a line. The line charge model is more accurate to reality because it takes this into account by summing the electric field and force at a large number of points across the line, in contrast to the point charge. That is all. Have a great day.